On section 12.3, we're going to discuss about finding the arc length of a particle traveling in space. Alright, so we're going to go back to a formula that we have already used in Calculus 2 when finding the arc length using the integral. Okay, the formula for the arc length of a function, traveling along a curve, it is given by, like if I'm traveling from some point A to B, all I need to do is get the integral from A to B of the square root of the derivative of the function squared. Now when we're talking about a vector, it is going to be the same thing, but keep in mind that a vector consists of three components. We have the I component, the j component, and the k component. That gives us a position r's of t of any specific vector. So if I want to find the length of the curve that the vector has traveled from a point A to a point B, okay, what we have to do, we use the same formula that we used in the integral before, which is the integral from A to B of the square root of, but in this case we're going to get the partial derivative, the derivative of the components, the derivative of the I component square plus the derivative of the j component square plus the derivative of the k component square. But now, what does that give us? If you recall, if I get the derivative of all the components, my I, j, and k component, that is basically going to give us the same as the velocity vector. Okay, so this will basically be the same thing as just getting the velocity vector. Okay, so let's go ahead and start looking at some of the questions here about the arc length of a particle in space. First one, it says find the arc length per parameter. So this parameter means basically we want an equation in terms of the parameter t that will give us the arc length from any point A to any point B. So first thing that we need to do is that we need to get the derivative of this vector. Okay, so we're going to get the derivative of this vector r's of t, and that's going to be the velocity vector, if you recall. So right here we need to use the product rule for the derivative, because we have u times v. So we're going to get u times the derivative of v plus v times the derivative of u, right? So u, which is 3e to the t power, times the derivative of cosine. The derivative of cosine is negative sine, so that would be the same as negative 3e to the t sine of t. Now, plus v times the derivative of u, which is plus cosine of t, times the derivative of 3e to the t power. The derivative of 3e to the t power is just going to be 3e to the t power. So it's just going to be plus 3e to the t power times cosine of t. That's going to be my I component. Now, for the j component, we also have to apply the product rule. This is u, 3e to the t. This is v, sine of t. U times the derivative of v, so it would be 3e to the t times the derivative of sine of t, which is cosine of t. So it would be 3e to the t times cosine of t, plus v times the derivative of u, which is sine of t, times the derivative of 3e to the t. The derivative of 3e to the t is going to be 3e to the t. So it's going to be plus 3e to the t power sine of t. And that is my j component. And plus the k component, well, it's going to be a minus actually. The k component, you see it's the derivative of 3e to the t, it's going to be just 3e to the t. So what we need to do next is we need to get the absolute value of this, okay? Because if I get the derivative and then I square it, you will see that if I get the derivative and I square it, that would give you exactly the same thing as just getting the magnitude of the velocity vector. So just think of a simpler example so you can see how that formula actually works. This that we're given right here. So if I give you just a very simple formula, let's think of just ti plus t squared j. Let's think of that. What happens if I get the derivative of that? Very simple. So you get I plus 2tj. Right? So if I get the square root of that, now think of it as a square root. Think of it this way. So what happens if I get the square root of each of the components square? It would be 1 square, which is the I component, plus 2t squared. But that is the same as the square root of 1 plus 4t squared. Yeah? So, but what if I get the magnitude of this vector? This vector is the same thing as the velocity vector, right? So that would be the same thing as the magnitude of v. So if I get the magnitude, is the same thing as getting each one of the components square, right? But guess what? This is going to give us the same thing as that. So that's why they say that when I get the square root of each of the derivative of each component square, that gives us the exact same thing as the magnitude of the velocity vector. Okay? This simple example proves it right. Okay? Now, let's continue, and basically I'm going to use it as the magnitude because I think that's going to be a little bit faster to do. So, let's go ahead and get the magnitude of this velocity vector. I'm going to change the size because I'm going to be writing a lot. To get the magnitude, we're going to get the square root of each one of the components squared, right? So it would be negative 3 e to the t sine of t plus 3 e to the t cosine of t squared. Then plus the j component squared, which is 3e to the t cosine of t plus 3e to the t sine of t squared. And last but not least, plus the negative 3e to the t squared. This was my k component. I forgot to put the k component right here. So, let's get the magnitude and let's see what we get here. We're going to square these. So if I square this binomial, it's going to be the square of the first term, which is, if I square this, that's going to give us 9e to the 2t times sine square of t. I'm squaring the whole thing, right? Plus 2 times this term times this term. So 2 times 3e to the t times negative 3e to the t, that would be negative 9 times 2, which is negative 18. So I'm going to have a minus 18. E to the t times e to the t would be e to the 2t, right? Times sine of t times cosine of t. Then plus the second term square. So if I square this term, 3e to the t squared would be 9e to the 2t, and then cosine of t squared, it would be cosine square of t. Then I'm going to do the same thing with this binomial. The first term square, so 3e to the t cosine of t, if I square it, it's going to be 9e to the 2t times cosine square of t. Then plus 2 times 3e to the t cosine of t times 3e to the t cosine of t, that would be 3e to the t times 3e to the t, that would be 9e to the t times 2, double, that will be 18e to the 2t. So this is e to the t times e to the t. Cosine of t times sine of t would be sine of t cosine of t. Then plus the second term square, 3e to the t sine of t squared would be 9e to the 2t times sine square of t. And then I have to square the last component. If I square the negative 3e to the t, that would be 9e to the 2t. Now, the next thing that we need to do is we need to see if any of the terms are going to cancel. So we have, you see that negative 18e to the t sine of t cosine of t plus 18e to the 2t sine of t cosine of t. Those two will cancel out. Then what else do we see there? Let's check out if there's anything else that cancels or if we can combine any like terms. We have a couple of like terms that can be combined. 9e to the 2t cosine of t plus another 9e to the t cosine square of t. We can combine these two, right? That will be 18e to the 2t cosine square of t. Also, 9e to the t 9e to the 2t sine square of t plus 9e to the 2t sine square of t would be 18e to the 2t sine square of t. So all combined, we're going to get the following magnitude of the velocity, which is, we said, 18e to the 2t sine square of t, then plus 18e to the 2t cosine square of t, and then plus the last term, which is plus 9e to the 2t. Look at what happens next. We can factor the e to the 2t from all of them. Basically, a 9e to the 2t, we can factor it from all the terms. So if I factor the 9e to the 2t, we're going to be left with this. 2 sine square of t plus 2 cosine square of t plus, that will give us a 1. Let's remember one thing. Sine square of t plus cosine square of t, that's our Pythagorean identity. That equals to 1. So these two, they're just going to equal to 2. Right? Because this is the same as 2 times sine square of t plus cosine square of t. But this is going to equal to 1 times 2, which is just going to be 2 plus 1, and that's going to be 3. Right? So all of this just gives us a 3. So my velocity, the magnitude of the velocity would be 9e to the 2t times 3. Right? But then we can get the square root of this term. The square root of 9e to the 2t, it would just be 3e to the t. And then the square root of 3, of course. Okay? So this gives us the magnitude of the velocity. Okay? Now, if I want to find the arc length parameter, so that would be basically in a formula that will calculate the arc length at any value of t, from any two points in the from any two values of t along the curve. Okay, all we have to do to find the arc length parameter is the following. We're going to integrate it from 0 to the letter t. And that's going to give us an equation in terms of the letter t for that for the arc length of this particle. Okay, from 0 to t, always from 0 to t of the magnitude of the velocity, and of course dt, because it is in terms of t. Right. So that's going to give us this: the integral from 0 to t of the magnitude of the velocity, which is 3e to the t times the square root of 3 dt. If I integrate it, the integral of e to the t is still going to be e to the t, and this is just a constant, right? So the 3 square root of 3 is just a constant. So I'm just going to leave it like this. So the integral of 3e to the t square root of 3 is going to be the same as 3e to the t square root of 3. And we're going to integrate it from 0 to t. So if I evaluate the t first, that's just going to be 3e to the t, because I'm just replacing the t back, but it's already a t, right? Square root of 3, minus f of b, which is evaluating it at t, and then minus f of a, which is evaluating it at 0. So if I evaluate this at 0, it would be minus 3e to the 0 square root of 3, but e to the 0 is 1. So that would give us the same as 3e to the t square root of 3 minus 3 square root of 3. This is the equation that for the arc length parameter, meaning that at any 2 points along the curve, at any 2 given values of t along the curve, is going to calculate the arc length of the particle. Okay, so I'm going to prove it to you, and we're going to just do the arc length formula in 2 different ways, using the regular method and then using the arc length parameter formula. Okay, so let's go back now. The second part of the question says, find the arc length at the indicated point in the curve. So we want to find the arc length from negative natural log of 4 all the way to 0, between those 2 values of t along the curve. Okay, so if I use the arc length parameter, all I have to do is evaluate it. So substitute the negative ln of 4 first, and then it's like if you were doing f of b minus f of a. So the arc length from negative 4 to 0, from negative ln of 4 to 0 would just be evaluating, so we don't have to integrate it anymore. So this is the arc length parameter, this is the formula. All I have to do is evaluate it from the negative ln of 4 all the way to 0. So let's go ahead and do that. So if I put the 0, first of all, f of b, which is going to be 3e to the 0 square root of 3 minus 3 square root of 3, then minus f of a, which is 3e to the negative ln of 4 square root of 3 minus 3 square root of 3. Okay, so let's see what we get. That's going to give us, this is going to be 1, so that's 3 square root of 3 minus 3 square root of 3, this is 0, right? Then right here, when I evaluate this one, that negative, remember that's the exponent of the 4, so basically that's going to be the same as, well, distributing these negative, that's negative 3 times e raised to the ln of 4 to the negative 1. Remember that negative means 4 to the negative 1 square root of 3 minus, and if I distribute this negative here, that's going to be a plus 3 square root of 3. Right? So what happens here, remember that the ln and the e are opposite operations, so this is an inverse property. They simplify each other, right? So we're left with the following. Arc length is equal to negative 3, hold on, negative 3 times 4 to the negative 1 power plus 3 square root of 3. Oh, I forgot the square root of 3 before that. Let me just write it right here. Plus and then 3 square root of 3. Now 4 to the negative 1 is just the same as 1 over 4. So the arc length is going to give us negative 3 square root of 3 over 4. That 4 goes to the bottom. Plus 3 square root of 3. Now right here, in order for us to be able to add them, we need to have the same denominator. So I need to multiply this one by 4. Right here and right here. So we can be able to add them. So the arc length is then going to be negative 3 square root of 3 over 4 plus 3 times 4 is going to be 12 square root of 3 over 4. When I add them, negative 3 plus 12 is going to be 9 square root of 3 over 4 units. So that means that if we were to sketch the curve between the values of t equals negative L natural log of 4 all the way to 0, we would see, if we count the number of units, it will be approximately 9 square root of 3 over 4 units long, the length of that curve. Now, this is by using the arc length parameter formula that we obtained. But again, I can also find the arc length using the regular formula that we did. Remember that the velocity vector, the magnitude of the velocity was equal to 3e to the t, the square root of 3, right? We can directly evaluate it. This is another way. I'm going to put it as method number 2 here. We can directly evaluate it by doing the integral formula. Since we want to find the arc length from negative natural log of 4 to 0, we're going to get the integral from negative natural log of 4 to 0 of the magnitude of the velocity dt, but the magnitude of the velocity is 3e to the t square root of 3 dt. Now let's go ahead and do it this way, and we're going to compare the answers. So integrating the 3e to the t square root of 3 dt is just going to be 3e to the t square root of 3. And we're going to evaluate it from negative natural log of 4 all the way to 0. So let's do that. So if I replace the 0, that gives us 3e to the 0 times the square root of 3 minus f of a, which is evaluating the bottom limit, which is 3e to the negative natural log of 4 times the square root of 3. Okay, I'm not going to go through all the algebra again. We did some algebra that we should know from the right side. This is going to be 1, so that's just 3 square root of 3. And remember that this is the same thing as 4 to the natural log of 4 to the negative 1, but natural log of and e will eliminate each other, so that's the same as minus 3 times 4 to the negative 1 times the square root of 3, but that is the same as 3 square root of 3 minus 3 square root of 3 over 4. And then if we want to make the same, combine these two, we need to put them over the same denominator. So we multiply this one by 4. Guess what? So this is going to be a 12 square root of 3 over 4 minus 3 square root of 3 over 4. And that is the same thing as 9 square root of 3 over 4 units. So whichever way we evaluate it with the integral formula or finding the arc length parameter and then evaluating it, it should give us the exact same arc length. So the length of the curve from between the values of t equals negative natural log of 4 to t equals to 0 is equal to 9 square root of 3 over 4 units long. Let's go ahead and do one more example of finding the arc length. A couple of more examples here. Let's find the arc length parameter on this one, the formula that will calculate the arc length at any 2 points on the curve. Alright, so first of all we need the derivative of the position vector, which again, that's going to be the velocity vector. So the derivative of 4 is going to be 0. The derivative of 2t is just going to be 2, so it's just going to be 2i. The derivative of 6 is 0. The derivative of 5t is just going to be 5, so that's equal to 5j. The derivative of 1 is 0. The derivative of negative minus 3t is going to be minus 3, so that's minus 3k. Now, let's go ahead and find the magnitude of the velocity. That would be the square root of 2 squared plus 5 squared plus negative 3 squared. So the magnitude of the velocity is going to be equal to square root of 4 plus 25 plus 9. That's the square root of 38. And we cannot reduce this, so it's going to stay as is, right? So how do we find the arc length parameter formula? So the formula for the arc length in terms of the parameter t. So we're going to integrate it from 0 to t. Okay? So of the magnitude of the velocity, which is the square root of 38 dt. And let's keep in mind, when we integrate a constant, we just need to put the variable in it. So the integral of the square root of 38 dt would just be the square root of 38t. Right? So, and then we're going to evaluate it from 0 to t. So if I do that, then that's going to give us the square root of 38t minus the square root of 38 times 0. I replace the t first, and then I replace the 0, right? F of b minus f of a. So then, the arc length, the formula that calculates the arc length at any 2 points in the curve in terms of the parameter t, it's going to be given by the square root of 38t. Now, it is up to you now if you want to find the arc length using the formula, so you don't have to integrate it again, just using the formula for the arc length parameter. You just evaluate it between the two given values of t, f of b minus f of a, so you don't have to integrate it anymore. Or you can do the integral completely to find the arc length. The integral from a to b of the magnitude of the velocity in terms of t dt. Let's just use just the arc length parameter since we already have it. Let's find the arc length right here from this curve using the formula for the arc length parameter between the values -1 and 0. That's what they want right here. We want to find the length of the curve between those two values. So we just do f of b minus f of a would be the square root of 38 times 0 minus the square root of 38 times -1. So then the arc length is going to be the square root of, the square root of 38 times 0 is just going to be 0, right? Then the square root of negative square root of 38 times -1 would just be the square root of 38 units long. So that means that the length of the curve between the values between -1 and 0 will be approximately square root of 38 units. Now, this is a little bit of a different problem. Let's think about this. Problem says, find the point on the curve r of t equals 5 sine of t I plus 5 cosine of tj plus 12 tk at a distance 39 units along the curve from the origin in the direction of increasing arc length. So in other words, we want to find the point on the curve at which point is the curve going to be measuring, is going to have an arc length of 39 pi units. Okay, so basically we want to find, like if I do the arc length formula, from 0 to some point x. We don't know where, to what point do we have to integrate it, or to what value of the parameter does it need to stop, so that the arc length right here, it's going to be the same as 39 pi units long. Okay, so we're going to integrate it. Okay, we're going to do the whole formula in terms of the parameter t to find the arc length, but we already know the arc length. All we need to find is until which point until which value of t does it need to stop so that the arc length measures this much. And then we're going to find the point on the curve by using the position vector. Okay, so first of all, let's go ahead and do it like this. So it would be the arc length, which is 39 pi, is equal to the integral, but first we need to find the magnitude of the velocity, so let's go ahead and do that part right here on the right. So get the velocity vector by derivating this. Let's get the derivative. The derivative of 5 sine of t would be 5 cosine of t. and that's my I component. The derivative of 5 cosine of t would be minus 5 sine of t, and that is my j component. And then the derivative of 12t, that would be 12, and that is my k component. Now let's get the magnitude of the velocity vector. So 5 cosine of t squared plus negative 5 sine of t squared plus 12 squared. So that's going to give us the following. 5 cosine of t squared would be 25 cosine square of t plus negative 5 sine of t squared would be 25 sine square of t plus 12 squared is going to be 144. Remember what happens here. Sine squared plus cosine squared equals to 1, so that just equals to 25. 25 times 1, which is 25. Right, so we get the magnitude of the velocity equals to the square root of 25 plus 144, and that is equal to the square root of 169, which is equal to 13. So let's go ahead and now find the value that it must be integrated to, so that the arc length equals to 39 pi units. So the arc length, which is 39 pi units, equals the integral from 0 to some point x of the magnitude of the velocity, which is 13 dt. Let's integrate it and let's find it. So that's 39 pi equals to the integral of 13 dt would be 13t, and we're going to evaluate it from 0 to x, some x that we're looking for. So that's 39 pi equals to 13x minus 13 times 0, so that would just be 13x. So 39 pi equals to 13x, then divided by 13, that would be equal to 3 pi. So in order, what this is telling us right here, that in order for the particle to have an arc length of 39 pi units long, then it must travel from t equals to 0 all the way to t equals to 3 pi. Okay, so this is the limit that it must travel to. It must travel all the way to 3 pi. So now I want to find onto what would be the point on the curve where it has to stop so that it has this length. To find the point on the curve, that means the position. So we're going to go to the position vector, which is r of t, but t is going to be evaluated at 3 pi, so we can find the point on the curve that it's going to be at 3 pi, when t is equal to 3 pi. So it would be 5 sine of 3 pi I plus 5 cosine of 3 pi j plus 12 times 3 pi k. So the position at 3 pi is going to be sine of 3 pi is going to be the same as 0, because that's the same. 3 pi is basically the same as the 180, or pi. Pi is the same as pi, right? So, and sine of pi, it's going to be 0. So this is going to be 0i plus cosine of 3 pi is the same thing as cosine of pi, but cosine of pi, it's going to be -1. So I'm just going to put it as -1 right here, so it would be minus 5 j, and 12 times 3 pi would be plus 36 pi and k. So at what point on the curve is the arc length from the origin? Is the arc length going to have a length of 39 pi units long at the point 0, -5, and 36 pi? This is the point at which the length of the curve from the origin all the way to this point, it's going to have a 39 pi units long. The arc length will be 39 pi units long. Okay. All right. This is the next and last definition that we have on this section. It is about the unit tangent vector. The unit tangent vector will be nothing else but basically the direction of the motion of the particle. Okay, it's basically known. We kind of introduced that before. If you remember v divided by the magnitude of v, we mentioned that that's the direction of the motion. But that is also the same as the unit tangent vector, because the velocity would be the tangent of the position of a particle at any point in the particle's path. So that's going to be the direction of the motion in which the particle is moving. Okay, so any direction, remember when we divide the vector divided by its magnitude, that is the unit vector that represents the direction of its motion. Its direction basically. Okay, so in this question, we want to find the curve's unit tangent vector and then find the length at the indicated point of the curve. Alright, so to find the unit tangent vector, we need to find first of all the velocity vector. So the velocity will be the derivative of the position. So the derivative of 4 cosine of t would be negative 4 sine of t I. Then the derivative of 4 sine of t would be 4 cosine of t j. And the derivative of the square root of 2t would be the square root of 2k. Now we need to find the magnitude of the velocity. That would be the square root of negative 4 sine of t squared plus 4 cosine of t squared plus the square root of 2 squared. So the magnitude of the velocity, it's going to be equal to, that would be 16 sine square of t plus 16 cosine square of t plus 2. But remember that sine square of t plus cosine square of t equals to 1, so that's just going to be 1 times 16, which is 16 again. So 16 plus 2, that would be the square root of 18, and that is the same thing as square root of 9 times 2, which is 3 square root of 2. Now, if we want to give the unit tangent vector, that is represented by capital T. That is given by the velocity vector divided by its magnitude, because remember the unit tangent vector is nothing else but the direction of the motion. This is the direction of the motion. So the vector is going to be negative 4, the velocity vector is negative 4 sine of t I plus 4 cosine of tj plus the square root of tk. But we're going to divide it by its magnitude, which is each component divided by 3 square root of 2. So that's going to give us negative 4 divided by 3 square root of 2 sine of t, this is my I component, plus 4 divided by 3 square root of 2 cosine of t, and this is my j component, and then plus square root of 2 divided by 3 square root of 2, that would be my k component. The only thing I can do is we can rationalize, we don't really have to, but the only thing that we can do is simplify this k component, and that would just be 1/3. Okay, and this gives us the unit tangent vector. So that would be the same as the direction of the motion at any point in the particle's path. Second part of the question we need to answer is find the length of the indicated portion of the curve. Now we can either, we're not being asked for the arc length parameter formula, so you can either find the arc length parameter formula or evaluate the integral directly from the magnitude of the velocity. So I'm going to do it directly because I don't have the parameter formula. So to find the arc length of the portion of the curve, we're going to evaluate the integral from 0 to pi of 3 times the square root of 2 dt. So the arc length is 3 times the square root of 2. The integral of 3 square root of 2 dt would just be 3 square root of 2 t evaluated from 0 to pi. And so the arc length is f of d, which is 3 square root of 2 times pi, 3 square root of 2 times pi, minus f of a, which is 3 square root of 2 times 0. And that would just give us 3 square root of 2 pi units. So the particle measures 3 square root of 2 pi units from 0 to pi. Now let's go ahead and do a couple of more examples before the end of the section. The next one, find the curve's unit tangent vector and also find the length of the indicated portion of the curve. So, to find the unit tangent vector, first thing, which is the direction of the motion of the particle's path. So we need to first find the velocity vector, which is the derivative of the position vector. For t, the derivative of 4t would be 4, so that would be 4i, plus the derivative of t to the 3 halves, you multiply the 3 halves to the front, so it would just be this, multiply the 3 halves, and then subtract 1 from this exponent. 3 halves minus 1 would just be 1 half. And that is my k component. There is no j component. Alright, 2/3 times 3 halves, they simplify each other to 1. So my velocity vector is going to be given by 4i plus t to the 1/2 k, which is the same thing as the square root of tk. Right. So next, what do we need to do? So we need to find the magnitude of the velocity. To find the magnitude of the velocity would be this component square plus this component, which is the k component square. There is no j component, so it's just the I and the j and the k. So that would give us 16, and then plus t to the 1/2. If I square it, it would just be t, because this is the square root of t squared. It would just be t by itself. So, and there's nothing to simplify. So this is the magnitude of the velocity. So if I want to give the unit tangent vector t, this is going to be the velocity vector divided by its magnitude. So we're going to divide this vector by its magnitude. This is 4 divided by the square root of 16 plus t. That's my I component. Plus, and then t to the 1/2, or the square root of t, divided by the square root of 16 plus t. This is my k component. And this is the tangent, unit tangent vector, or vector, the direction of the motion. Second part of the question, we're going to find the length of the indicated portion of the curve. To find the length of the curve, we want to find the arc length from t is equal to 0 to t is equal to 20. We can either find the arc length parameter, or we can directly evaluate it through the integral from a to b, which is from 0 to 20, of the magnitude of the velocity dt. The magnitude of the velocity is equal to the square root of 16 plus t dt. So, let's keep something in mind right here. That square root means 16 plus t to the 1/2 power. So we're going to use the power rule to integrate this. The power rule says that first of all we need to make sure that we have the derivative of this function on the outside. The derivative of 16 would be 0. We don't need it. The derivative of t would be dt. We already have it. So this is the same thing as a function u raised to the n power, and the formula would be u to the n plus 1 divided by n plus 1. So which is going to be the same as u, which is 16 plus t raised to the n plus 1. So if I add 1 to this power, 1/2 plus 1 would be 3/2, but we're going to divide it by 3/2. And we're going to evaluate it from 0 to 20. But that divided by 3/2 is the same thing as multiplying this times 2/3, right? And we're going to evaluate it from 0 to 20. So let's do the evaluation. I'm going to continue down here. So that's going to be f of b. So it's 2/3 times 16 plus t, which is 20 raised to the 3/2, minus f of a, which is 2/3 times 16 plus 0 raised to the 3/2. So this is 36. That 36 means the over 2 means the square root of 36, which is 6, but then 6 raised to the 3rd power is 216. 216 times 2 is 432 thirds. The next one, 16 plus 0 is 16. The square root of 16 is 4. 4 raised to the 3rd power is 64. 64 times 2, it's going to be 128. So that's minus 128 thirds. And when I subtract them, that would be 304 thirds units. This is the length of the curve from t is equal to 0 to t is equal to 20. If we start graphing the curve, you can always check the graph just to understand with more clarity what this is telling us. This is telling us that if the particle starts traveling from t is equal to 0, t equals to 1, t equals to 2, t is equal to 3, all the way to t is equal to 20, this is going to be its approximate length from beginning to end. Okay, so let's go ahead and do one last example here, and we're going to answer this one, since this is going to be a little long one. Let's find the unit tangent vector and find the length of the indicated portion of the curve. So for the unit tangent vector, we need to find the derivative of the position. This one, it's going to be the product rule, u and v. So u times the derivative of v, so the derivative of cosine would be negative sine, so it would be negative t times sine of t, plus v times the derivative of u, the derivative of t would be 1, so it would be 1 times cosine of t, which is just cosine of t. This is the I component. Now, for the j component, we're going to do the same. This is u and v. U times the derivative of v would be the derivative of sine of t is cosine of t, so it's negative t times cosine of t, plus v times the derivative of u. The derivative of u is the derivative of negative t is negative 1, so that would just be negative 1 sine of t, which is just negative sine of t. That's my j component. And last but not least, 2 square root of 2 over 3 times t to the 3/2. The derivative of t to the 3/2, you multiply the 3/2 times the coefficient, which is 2 square root of 2 over 3 times 3/2, and then you subtract 1 from the exponent. 3/2 minus 1 would be 1/2, and that is my k component. So this last component, I can reduce it, so I'm just going to simplify it. So we're going to be left with negative t sine of t plus cosine of t I plus negative t cosine of t minus sine of t j plus right here 2/3 and 3/2, they can simplify, so you're left with the square root of 2 times t to the 1/2 k. Or you can write it also as square root of 2 times the square root of t, which is the same thing as the square root of 2t. So I guess it would be best to write it in the most simplest form, because the t to the 1/2 means the square root of t, so I'm just going to put it under the square root. That's the same as t to the 1/2. Alright, So that's the velocity vector, but now we need to find its magnitude. So it would be the I component, which is negative t sine of t plus cosine of t squared, plus the j component, which is negative t cosine of t minus sine of t squared, plus the k component, which is square root of 2t squared. Let's simplify this all the way to the end. So we're going to use the squaring the binomial formula. We're going to square the first term. If I square negative t sine of t would be positive t squared sine square of t. Then multiply these two and then double it. So negative t sine of t times cosine of t would be negative t sine of t cosine of t times 2 would be negative 2t sine of t cosine of t. And then square the second term. If I square cosine of t would be plus cosine square of t. Now, we're going to do the same thing with this one. Square the binomial. Square the first term. So if I square negative t cosine of t would be positive t squared cosine square of t. Then multiply these two. Negative t cosine of t times negative sine of t would be positive t sine of t cosine of t. Double it. So it will be positive 2t sine of t cosine of t. And then square the last component. So if I square the square root of 2t, it would just leave me with 2t. So the magnitude of the velocity is going to be equal to, let's see if we can do any combining right here. Let's take a look at it. Look at these two. First of all, t squared sine square of t plus t squared cosine square of t would just be t squared, because sine square of t plus cosine square of t is 1 times t squared is just going to give me t squared. What else do we see? Negative 2t sine t cosine t plus 2t sine t cosine t, they cancel out. And we're left also with the plus cosine square of t plus 2t. On this one, I believe this is as far as we can simplify. Okay, before we continue, I just saw that I missed one term before these 2t right here. I squared the first term, which is a negative t cosine of t, which was t squared cosine square of t. Then I multiply negative t cosine of t times negative sine of t, which is positive t sine of t cosine of t, and then doubled it. That's 2t sine of t cosine of t. But I forgot to square the negative sine square of t. So that's the part that I missed right here before the 2t. So if I square the negative sine t, that will give me positive sine square of t, then plus the 2t, of course. So before I actually write anything else down right here, what else do we see? That sine square of t plus cosine square of t, they equal to 1. So we're going to have the 2t, t squared, plus the 2t, and then plus that 1 that I got from those two. I'm just going to be putting it so you see where I got them from. So the 2t is what we have left right there, and the t squared, we got it from these two. What else? So actually we can still simplify this, because that is a perfect square trinomial. The factors of that would be t plus 1 times t plus 1. And that would be the same thing as the square root of t plus 1 squared, but the square root of t plus 1 squared would just be t plus 1. So yes, we were able to simplify way more. So then if I want to write the unit tangent vector t, we need to divide the velocity vector divided by its magnitude to get the what's called the direction of the motion. Okay. So we're going to divide each of the components of the velocity vector up here. Okay, so this is a simplified one. So negative t sine of t plus cosine of t divided by its magnitude, which is t plus 1. So it's going to give us negative t sine of t plus cosine of t divided by the magnitude, which is t plus 1. This is the I component for the direction of the motion. Plus, then we have the j component, which is negative t cosine of t minus sine of t divided by its magnitude, which is t plus 1, and this is the j component, then plus the square root of 2t divided by its magnitude, which is t plus 1, and this is the k component. And this gives us the unit tangent vector, which is basically the direction of the motion vector. Now, last part of the question we want to find is we want to find the length of the arc from t is equal to 0 to t is equal to pi. So let's go ahead and do the integral formula for the arc length. To find the arc length from t is equal to 0 to t is equal to pi, we need the integral from a to b of the magnitude of the velocity dt. So the magnitude of the velocity was t plus 1. So it would be t plus 1 dt. So if we integrate t, that would be 1/2 t squared, or t squared divided by 2. If we integrate 1 with respect to t, it would just be t. And we're going to integrate them from 0 to pi. So f of b would be 1/2 times pi squared plus pi minus f of a, which is 1/2 times 0 squared plus 0. This is just going to be 0. So all we're going to be left with is 1/2 pi squared plus pi, or we can just factor a pi and leave it as pi times the 1/2 of pi plus 1 units long. So in exact form, this is the how many units long the particle is going to be if we sketch it from t is equal to 0 all the way to t is equal to pi. And this pretty much covers mostly everything you need to know from the unit tangent vectors and finding the length of a curve at any values of t along the curve.